Paul, feel free to kick us off.
All right, thanks. Thanks. My name's Paul Works. I am the director of scenarios and wargaming at what used to be TRAC, Research and Analysis Center at Fort Leavenworth. Recently, TRAC and the Data Analysis Center at Aberdeen have merged, and that we've become one organization. So we're called the Transformation Decision Analysis Center. It makes both organizations a much larger kind of group of folks, but we're doing the same work, just have a slightly different name. So anyway, I do scenarios and wargaming at Fort Leavenworth. I've been doing it a long time. I've been doing hobby wargaming since the 1970s, and been doing professional wargaming since 1988, and then out of China Lake for the Navy, and then air-to-air wargaming, air-to-ground wargaming, and then I have done wargaming for the Army since 1998. And with that wargaming, we looked at everything from weapon systems to force structures to concepts of employment, concepts of uh, operations, and so on. And so we've looked at a bunch of different. I've looked at a bunch of different things. So I have a broad experience. What I'm going to talk to you today about is how we do wargaming at TDAC in support of capability development and concept development. And by capability development, I mean that when the Army wants to buy a new weapon system or reorganize or change how we operate, that will eventually become doctrine. That's what capability development is. And it includes the part of the acquisition process and so on. And then concept development is developing, helping, doing experimentation, looking at how we would employ future weapon systems and so on in a future battlefield. So typically, just to give you a kind of a scoping, typically what we do at TDAC Fliven is we look at battles that are occurring in 2040, 2050 timeframe. So we're looking out there. We also do more near-term stuff, but mostly it's looking at those kinds of situations. So you can kind of get that image in your mind of how we do stuff, what we examine. So the agenda, you can see it right today. We're going to be looking at some theory, which for probably most of the people online, some of this stuff will be like, we'll go through it fast. The wargaming design development process is what we use at TDAC to do our design development, and then how kind of morphing the theory into analysis for analytic rigor for when we in the piece in the sense of how we execute analyses, and then how we tie wargaming into that, and then how we do analysis using the war games, and then kind of an example using the current Army doctrine multi-domain operations and the war game that we have developed, and how we put it all together and execute. All right, so this is a standard definition for wargaming from Peter Perla and others, and so I won't go into much detail about it. I mean, we're replicating real world operations, but not in the real world, right? And we even though we can pull numbers out of the tools that we have, like when we execute war games, look at unit losses and so on, and time to execute missions. Really, what we examine are the player decisions, why they're making decisions, interactions of different variables, and so on. And so that brings into how the narrative of how things take place in the war game. And a lot of times, the outputs from our war games feed other tools. So we would, like, for a closed form simulation that can run 10,000 runs, we can provide how the players make decisions to instantiate decision rules for the entities in those closed form simulations. So that's how we do that's kind of the basic theory. Now, I won't go into this much at all, but leave it. Just suffices to say that we understand the theory behind wargaming. We understand that it's not tight for a lot of reasons. There's a lot of fuzziness in it in the sense of because if you have a different set of players, they're going to make different decisions. You change the environment slightly that the players are interacting with. Some players may interact with the system visually better than the others. Some may interact more tactily, and so on. And so we put that all together and think about when we put our war games together, we keep this stuff in mind when we do that. So, but we do understand that there is a value with wargaming. The value of that, and I guess you're all in line because you like value, you understand the value as well. And that is because it's weakly structured like this, it allows us to examine problems that in ways that aren't tightly constrained by more hardcore simulations or models that we can stretch it a little bit. All right, so war games, it's not specifically game theory. There is some game theory involved in the sense of shelling and those guys, but it's not typically like that. That's not how we do it. Again, the outputs are typically not quantitative, although we can pull quantitative numbers out, and we use them to vet player comments, more qualitative comments, player decisions out of and vet those against those to see if there's discrepancies and so on. War games are typically not reproducible. Some of it has to do with the fact that most war games are stochastic. You're rolling dice, so the dice rolls make a difference, but also the players and the interaction between the players and so on. War games are resource intensive. When we run a war game, typically we have 20 some participants, players, uniformed players usually here for at least 1 week, if not 2 weeks. So that takes a lot of travel funds, and that doesn't include the analysts. So you have to include the analysts that wrap around those players that are doing the actual capturing the observations and so on. Okay, so then what we do is we use our war game outputs to provide inputs into what we call a data collection management plan. And the data collection management plan is a piece of a tool that every study uses, analytic study that describes, it links the study issues all the way down to what pieces of data you're pulling out of some kind of tool you're using, like a war game or a simulation, or even like an Excel model. And so some of those data elements you're capturing will be used to feed other pieces of the other tools that then you capture additional data from. So it's a very structured thing that we essentially it's a gigantic Excel table, although we can put it in Access or whatever, and leverage or other data manipulation tools, and to capture what we're pulling out of the war game. And a lot of it doesn't have they don't have to be quantitative numbers. These data elements that we're capturing, they can be qualitative. So you can see that down at the bottom that there's a lot of outputs that common outputs that we pull out are how we conduct operations, where critical decision points are, risks that have been associated with those courses of action, some conditions, things that the bad guys can do to counter what you're doing, and then pieces that solutions, like let's say it's a weapon system, some attributes of the solutions that you may have thought were valuable that may not be valuable, or there may be less valuable than you thought, or there may be an attribute that is more valuable than you thought, and so on. So that's the kind of polls you can pull out of there, out of war games typically. Okay, so now we're going to shift in the topics a little bit. This is the base wargame design and development process that we use. It's a combination of Peter Perla's book and Dunnigan's book, and some stuff we got from the Naval War College and the Army War College, and a slice of what some stuff we do. But anyway, essentially, because we're doing the stuff for a study, but we want to do a war game, we have to develop over on the top left. We have to develop what kind of requirements the customer needs, whoever that customer is, what kind of measurement space, and I'll talk about measurement space in the next slide, I believe. What kind of measurement space requirements you have, the data collection requirements, and then we do an extensive lit review, and then we go into the design development. Now, and you can see all those. I won't go through every one of those, but these are the key ones. So what we've done, and you'll see at the end of this presentation, we've done this to develop this process to develop a flexible and reusable wargaming system that we call the TWG, the TRAC wargame, and you'll see kind of as we go through the slides how we've applied this flow to develop that product. Okay, so here's measurement space. Measurement space is something that people use at TDAC and in other Army analytic organizations to categorize pieces of examining a problem under that you want to identify solutions to. And so other agencies use a similar construct. They don't call it measurement space. They may call it something else. So the components of this are not like novel, but it's a structured way that we use to execute a study. So the main part of it is the diagram on the top right, and that is measurement space is the intersection of the problem that you have, like, hey, we can't do this, we aren't able to defeat this bad guy, or whatever the problem is. And it's always a problem. It's never a need statement, so we have to characterize it that way. In the sense of you don't want to say a problem is something you need to do. So you need to do it, but why do you need to do it? What's the problem? Anyway, so then you have conditions that problem exists under, like what terrain it's in, what environment it is in, what time frame it's in, so on. And then you have a set of solutions that you have. And these can be anything from materiel solutions to TTP doctrine solutions, or so on. And that intersection of those helps us identify, okay, what attributes do we want to examine? What measures do we want to capture, like measures of performance, measures of effectiveness, and then how we need to instantiate those in tools within scenarios and as data outputs for the study itself. So then here's an example of a data collection management plan. It's hard to read on this, but if you blow it up, you can see that it links the study issues on the left, as I mentioned before, all the way over to the right to methods, models, and tools that are what tools we use to capture those data elements that then feed different measures of performance or measures of effectiveness. And then all this is mapped so you can see, okay, hey, we're collecting this piece of data because it's going to feed this mom, and it's addressing this EEA, and it may address part of another EEA, essential element of analysis. So that's it's another structured way of doing things. So as you can see, you probably can tell already, the way we execute analyses at TDAC is very structured. It's not regimented per se, not prescribed, but we have a lot of tools that we use and best practices that we leverage to ensure that over time people have come up with that, found that these work well. So the DCMP is one of them. So wargame applications to the measurement space is, let's look at each one of these. The problems, we can identify what pieces of the problem are really the problem. So when you do the war game, you execute some kind of military operation in the war game. The players may are delving into why that problem exists the way it exists, and then other potential considerations that are associated with that problem. You may find that you might find a very simple solution to the problem. Often that's not true. However, then when then you apply it to a set of conditions, maybe it's the conditions that are really causing the problem. By that, I mean, is the fact that the ranges in one theater are so long that that's the major problem. And so how do you solve that particular issue? Um, then the set of solutions, when you come up with these emergent solutions, what are the aspects or attributes of the solutions? And then are there risks associated with it? Is it, for example, hey, here's a proposed solution that you may have, but can the adversary do something to easily counter that solution and make it not as valuable as you may have thought of, etc. Okay, and then to the data collection management plan, the war game specifically feeds pieces of the data collection management plan, as I've mentioned before. And so, again, they can be qualitative outputs or quantitative outputs if you choose to do that. And I'll describe a challenge with quantitative data in a little bit. And I think, yeah, it's on the next slide here. So when you do quantitative data with war games, it's best, we found it best to do some type of design of experiment, in the sense of, hey, if we're going to look at 3 different alternative solution sets, and there are 4 variables associated with each one of those solution sets, and we may have 2 types of threat, then you can already see you're getting a lot of different iterations you can play with. But you can, and usually we don't have enough time to do every single permutation. Invariably, we don't. So we have to group those into solution sets, and then we have to build out a design of experiments that has the components that are as independent as possible. And so these are a couple of examples of how we try to do that. Now, you're never going to get a set of runs that are completely statistically independent from each other, but that's okay with wargaming. So you can see a couple different DOE structures that we use. Often we use that Latin hypercube process, and then a very loose example of that is the bottom right one from the Civil Affairs Force Modernization Assessment that we did a few years ago. All right, so now we're going to go into how we do analysis using our war game. So the basic process that we use leverages this pyramid, cognitive hierarchy pyramid over on the right. And essentially, you go from the bottom, which is, hey, we're capturing a bunch of observations, we're developing some information out of that, we're building out some knowledge, and then ultimately we get to some insights that are leveraged to feed the study, answer the study issues, and or some pieces of the information or knowledge may feed other MMT or MNS that are being used to support the study. So it's building out each one of those, and there's a kind of a general process that flows through that. And I think the next slide shows it in a little bit better way. So you have all these observations from a bunch of different people. Some people collect observations on the same thing. They're listening to people talk. Some of those observations may be actual collected quantitative data that are coming out of the tool. So you collate all those observations into a narrative so that you have a kind of a timeline of what happened and the actual facts of what happened. And you can kind of see some examples of there down below that under the information column, which is, hey, this happened and this happened. This says how many bad guys got shot, and this is how many of our guys got killed, etc. Then when you link that to the more detailed player decisions to build out the actual kind of a feel for what the operational effects are. So when an example would be, as you read those, is, hey, this many red guys get killed, so that forced them to modify their course of action to do something else, etc. So that's the kind of knowledge that would be pulled out, that we build out there. And then over on the right is where you build out the insights. So you say, okay, based on the fact that the Reds' scheme of maneuver was modified, that allowed the blue players to do this other thing. So it appears that this application of this weapon system or weapon system technology would be beneficial within the structure of the operation. So that's the flow of how that plays out. Now, one thing that's always important is, of course, communicating the results to your sponsor. So whoever that is, whoever your customer is, our customers may be anybody from the T2 com commander to the FCC commander, subordinate. That's a subordinate organization, command under the T2 com, or maybe the chief of staff of the Army, maybe OSD, maybe somebody else. So those are the kinds of customers we have. So typically what we do is we walk through how the war game applied to the DCMP, how it addressed some of the EEA study issues, and then describe through what happened in a war game using that contextual narrative that we developed using that process previously. And then utilize a lot of visuals, use a lot of categorizations, and you can see some examples over on the right-hand side where we've done that. And then you want to leverage the quantitative data pretty carefully so that you don't imply or actually explicitly state things that really are not statistically valid. For example, I've seen war games that have been done where they do one run of the war game, and then they'll say, and I know that the structure is stochastic, they're die rolls, and they'll say, hey, we use this technology, we killed 27.2% of the enemy. Well, that's ridiculous. I mean, you can't say that with just one run of the war game. So, however, you can do some kind of Likert scale, and so you can present almost the same amount of type of information, but just have a little bit more rigorous in your description of what was going on. And then always it's best to have uniformed guys or participants that you had in your war game helping the outbrief to the customer. That's always useful. And it's useful to have those participants help you flesh out the slide, review the slides and modify things if you have them slightly off. Okay, so now we're going to go into talking about an application of applying wargaming to examining how we conduct operations using multi-domain operations. So the first thing is, this comes straight out of the U.S. doctrine and the MDO concept, multi-domain operations concept, and that is these are the current and emerging operational environment. You can see, I'm not going to read every one of them, but it's complex. It's going to be urban. You're going to be against some near-peer threats. Unmanned systems, of course, that's like, always going to be there from now on. And then advanced technologies, that would include AI and that whole thing. So very complex environment. So whereas in the past where we might be able to do some Army wargaming where we just kind of focus on what the Army's doing on the ground, well, you can't do that anymore. That's not the way we can execute games. So as part of that, the MDO, Army doctrine, has this construct of, okay, all the different domains that are on the left-hand side of and the diagram of the different pieces, different domains of operations, and you can see in land, maritime, et cetera. But it includes all those, and then the geographic kind of framework and how the spaces, what's going, kind of a general idea of what's going on in each one of those areas you can see on the right-hand diagram. So, and then there's a base concept, and essentially it's to conduct distributed operations to synergize and coordinate in time and space to they call it disintegrate, but it's to attack the enemy formation and penetrate their anti-access areas, capabilities, and then defeat them. And so it's a structure of doing that. Now, one thing you can already get, if you haven't noticed already, is it's highly focused on the offense. And that has been a statement we've made to the doctrine people that, hey, maybe we ought to have a flavor of this that's more defensive, but U.S. Army, that's the focus of the U.S. Army for many years is offensive type operation. There are doctrine about for defense, but this kind of thing is focused on the offense. Okay, so here's the core competencies for MDO. Now, some of these pieces, I'm showing you these things because when we build out our war game, when we built our TRAC war game, we had to consider each one of those, each one of these. Now, primarily the bottom two main bullets, because the force posture and so on, that stuff is being done more by the guys, the war game teams and the analysts at the Center for Army Analysis. They do stuff more so like that. We take some of that information and leverage it for our scenarios and for our vignettes that we apply out of those scenarios. So our war game had that. So for example, we assume some set of forward presence of forces in our war game. So there's some start conditions. But when we execute the war game, we have to examine all these things in the bottom two main bullets. All right, so then we took doctrine. We did a lot of research and much research on warfighting functions, dynamics of combat power, and we MDO, and we looked at a lot of other research about how other people, both in DoD and commercial war games, actually, a lot of commercial war games, how they represented these various types of functions and combat power and domain. And we leverage those ideas. It's always best to leverage something that already exists. We leverage those ideas to address how we wanted to represent that MDO in our war game. So we developed some requirements, and then we spent about 2 years. Spent about a year developing the requirements, doing lit review. And if you've been to Connections or Moores, you may have seen us brief what we were doing a few years ago when we were building it. And then we delivered version 1 of the TWG in December of 2024 and version 2 in May of 2025. So we have a functioning capability, and this, I'll kind of go through each one of these bullets to describe what it is the TWG does. So it's a human-in-the-loop tool. We leverage a tool we already had developed, this VASTAR tool, which essentially is a MapX visualization capability with a bunch of other stuff wrapped into it. But that's our, the game has a board game feel, but it's on a digital platform. So there are some analog stuff that still people have to do because everything hasn't been built into the automated tool yet. So then we represent the environment in the TWG. Players play their assets, and they play their assets. They interact with their assets, and there are different ways they interact, and so on. And all the different types of domains you can see, and the warfighting functions. And we are able to pull out. We can link the player decision with the more rigorously developed mathematical structures that we have input into the TWG. So previously, a lot of times when we did war games, a lot of the adjudications were done using white cells, where you have a bunch of guys, gals sitting around a room. They look at the situation. They say, okay, well, I think that, and I'm kind of exaggerating a little bit, but they would say, well, we think that unit took 10% casualty. Well, so now we have a structure that says, okay, well, this is what the casualties are. And only the white cell, there's only any white cell involvement except if something odd happens, and usually it doesn't. Usually we have figured out most things. There are unknown things that happen, but they're different flavors. So then what we use for data is we use the Army pedigree data. They come from the JMIN, the Data Analysis Center, part of TDAC now, and other places, other program offices and so on, and then threat data to build out our unit characteristics data. And then we use historical combat results to scale the interactions between units, the adjudication and attrition between units. And then we deliberately use the war game as part of the study process within every TDAC study. So in every study we do, there's some type of war game that gets done. And the reason for that is because they don't know, there's always things that aren't hard defined of how things operate. So that you may have a new weapon system and you may have the capabilities and the attributes of it very well defined, but you don't know how you're going to use it. Not really. So that would require a war game. All right, so that's the basis of the TWG. Now I'm going to go through the next set of slides is going through what comprises the TWG. So this is a if you when you play the game, when you scroll over a unit icon on the game, it will pop up a little diagram that looks similar to this with a bunch of numbers around it. And those numbers look like a board game unit counter, and they describe all the what we call unit combat power values that describe the combination of combat power and warfighting function. So there's command control, there's intelligence, mobility, air missile defense, survivability, indirect fire, direct fire, and sustainment. So each unit has characteristics associated with it. It has a main value, and then there are sub-values associated with it. And these allow us to examine, this gives us the flexibility and the resolution to examine changes in weapon system capabilities and how it's aggregated up into larger units, not at a platform level. And so what we do is we build out our values at company level. So we'll take a company, which is usually generally homogeneous in its composition. So you, like a armor company is all tanks, right? And with may have some other stuff, a Humvee or two or whatever. But that's generally what it is. And then you aggregate that up to the battalion level, which is our general wargaming echelon level. And we have a structured way of doing that with some typical TTP that are used for the battalion and so on. Okay, so now I'm going to go into each one of the main functional areas of the TWG. The first one is direct fire. Typically, again, as I mentioned before, our main unit that we use is battalion. We have played games for scenario course of action development that are just at the brigade level. We can go down to companies, obviously, because we have company data. It's aggregated combat results. It's percent losses for a unit. The effects on those CPVs are not linear. So for example, if you take 30% losses, your direct fire value may go down by approximately 30%, but your command control value will maybe not go down by 30%, as an example. We don't do line of sight calculations because the hexes are 5 or 10 kilometers. The resolution for our war game does not support that. The combat tables themselves, which you can see an example on the right, is a differential column. Typically, what happens when you have one attacker attack a target, the attacker shoots at the target and the target shoots back. And so there's two sets of die rolls, one on the attacker side, one on the defender side, and they both are taking damage. So then there's die roll modifiers, which affect that are generally associated with weapon systems effectiveness. And then we have column modifiers, which are more that cause greater impact. Those that represent the tactical advantages or situations on the battlefield. Our base structure, the probability curves, are built using Lanchester equations, the Helmholtz variant of that. That Helmholtz variant, if you want information on it, I can get that. But it provides a number of different additional variables and how those variables are applied. And then we took that base set of attrition levels and we scaled it to meet historical combat data. So, and I'll just give you an example. If you just use base Lanchester equations and do a combat, fighting each other using those very quickly, if you know anything about Lanchester, you have such high attrition that it's not realistic in any way, and you'll be dead in a few minutes, hours, each unit. And so the Helmholtz variant allows you to use different allows us to use those die roll modifiers and column modifiers representing different aspects of the situation. But then even with the Helmholtz parameters, it runs pretty hot. So we had to scale it down. So I'll give you an example of scaling. So the Helmholtz and the Lanchester may say a 2 to 4 hour engagement of two combat formations, let's say battalions, produce 40% casualties. I'm just throwing out numbers. But so we looked at historical data, and granted, we scaled it down. Those historical data would say, no, really what's going on is you only take 5%. Those units would normally only take 5% attrition, depending on the situation and depending on who's who and so on. So we had to scale that. And why is that happening? Well, because when they don't just keep shooting each other while they're not all within line of sight of each other, they're not all shooting at each other every single minute. When one side has taken some significant casualties, which may be like 1%, then they may back off. And so there's all these dynamics in the real world that are taking place that are not being calculated or included in these Helmholtz variants. Okay, so then in addition to the damage, the percent losses, we have temporary effects, which are disruption, suppression, neutralization, that impact temporarily the unit capabilities to execute operations. End effect fire table, very similar. We use the Helmholtz variant again, but it's the area of fire version of that. We have capabilities that we have CRAM, which is the counter rocket, artillery, mortar capabilities that can degrade indirect fires. Again, we scaled it to meet combat data. And then with artillery, with fires, you can fire either suppression missions that are focused on suppression and neutralization, or you can fire missions that are focused on attrition. So the suppression neutralization, you're focused on disrupting the ability of the enemy unit to conduct operations, whereas the attrition one is you may not slow them down, but you may hit them with a little bit more attrition, the other type of mission. All right, for the air structure, air attacks, which includes electronic warfare, includes close air support, air interdiction, which are more deep kind of attacks. And they can also do, we have air superiority missions, CAD missions, ISR, et cetera. And so typically what we do is we do a turn uh, of air combat that occurs before the main tactical game takes place. We call it the operational game. And that air operations, what happens in the air operations defines the air superiority level, the air state for the blue and red sides for the game turned down in the tactical war game. So then it's very structured, kind of a structured flow of how the planes do it. And you can see an example of on the top right where you assign aircraft to various missions. They have to penetrate, they have to get through the air superiority level. So depending on, let's say you have the enemy has air dominance, so your ability to get task missions through that air dominance of air-to-air and high altitude air defense is limited. So you may only get a handful of task missions through. Then once you get your task missions through, they have to get through the medium range air defense and then the close in point defenses. So it's a very it's a detailed structure of how we execute it. Now, and then you can see the AMD, the air missile defense piece down on the bottom, where we have medium range air defense table that can cause aborted or degraded missions, and then the aircraft, depending on where you are on the combat results table, they can knock out the air missile defense capabilities either temporarily or physical damage. On this one, let me go back to this one very quickly. So a lot of the things that we have put together in this war game system, we pulled from other people. So this bubble layer thing you can see on the top right, we pulled that from CAA's JAWS wargame. So that concept is not novel, and other war games have various applications of it, but our structure, we pulled it from those guys. Now, command control. So command control in the next couple and intelligence, those are two things that are not quantitative data that we pull from our data sources. These are data. How this plays out is done. A starting point with the numbers of radios and networks that exist within the unit and the formation, but it's also how the leadership and the training of the unit and so on. And so we, because of the focus in MDO and in actually the new Army warfighting concept, which is details with systems warfare in detail, command control and your network structure, your ability to order your units around and have them coordinate is highly important. So we have to model command control in our working system. So we did a very detailed development of representing this. So we represent it by formation activations. Those activations are usually, depending on the war game we're playing, but it's usually sequential. So a red unit may activate, a blue unit may activate. And that red unit, let's say the units you're activating, if you're playing battalion level formation, you would activate a brigade, which has, let's say, 4 or 5 battalions. Those 4 or 5 battalions would do whatever they're doing in the war game, do their operation. They move, they attack, they do what they do. There are abilities for the red guys to interrupt the blue activation with their own operations and vice versa. But then after the blue brigade is activated, then you go to a red regiment, for example. Then they do their activation and so on. The activations of units themselves are done with the planning, the operational plan that are done by the players. So each game turn, the players lay out their plan for their units. As the units do their operation, if they want to modify that plan, essentially execute fragmentary orders, they have to expend command points that are inherent to their formation, their command, the headquarters in their formation, to allow them to do it. They also have to apply command points to do coordinated operations. So if you want to have two battalions attacking one enemy unit simultaneously, you have to use command points to execute that. So that, and you can see a kind of a structure over there on the top right of how that plays out. And if you are suppressed, neutralized, or disorganized, your ability to do a bunch of these different types of operations, even if you're activated, is limited. So there's that plays into it, and that's how that suppression, neutralization, and disorganization plays into getting units to move and so on. Intelligence is another one of the squishy things. The way we apply it is we apply it in two ways primarily. One is we apply it as a global COP. By that, we mean a formation COP, and we can make it down to a lower level, like, hey, this is a divisional COP, not a whole joint task force COP. But a lot of times it's just a global COP, and what that represents is the entire intelligence system that's on each side, like the blue side or the red side, that is developing a intel picture of the battlefield. And so you can apply an Intel ISR assets or Intel processing capability to build up your global COP and bring you up on the A through F level. And the better the level, the better picture you have of what's going on the battlefield. And that primarily affects long range fires or air interdiction missions, but it does have a smaller effect on direct fire engagement. The other way that you use intelligence, you can use ISR assets to directly impact direct fire combat. Or you can apply ISR assets specifically for specific fires missions. So you can say, hey, we're applying these 5 UAS to this particular 10-kilometer hex, and we're building out a very detailed targeting picture of that hex to feed whatever fires missions you have attacking there. And you can see there's an example that the game that I play all the time is a squad leader. So we made a conscious decision that in the 2040, 2050 time frame, the ability that you will know that units are out there. So we use a kind of a construct like this advanced squad leader thing, where you know that units are out there because of the prevalence of information flow, but you may not be able to target it. So and you may not know exactly what that unit is, but you know something's out there. So we don't play double blind, and so that forces people to. It allows you get the feel that, hey, you know those guys. There's a huge force out there, but you got to apply ISR assets to flesh out your understanding of that force, the enemy, and be able to actually engage it. Okay, sustainment, another thing that a lot of times in previous war games we kind of hand waved. We do work. We have done number of war games, and we have TDAC at TRAC lead that is focused on sustainment operations and sustainment analysis. But a lot of times, because of the numbers because of our run design limitations and how many runs we can execute during a war game, sustainment was kind of a secondary representation. And there are lots of examples of that. So for example, so in ours, and here's another piece, we always would have a sustainment player, a sustainment uniformed dude or dudette. And after the first part of the briefing, each game turn, that person didn't do hardly anything the whole game turn. So they'd be sitting around for several hours doing nothing. So we said, okay, well, based on those two pieces, we're going to apply a structured set of sustainment representations in the TWG. And this forces the sustainment player to plan out a sustainment plan, to lay out the MSRs and how they're getting, which units are being supplied, where the priorities are, and so on. And we have the version 1 of the sustainment, which is a more, we track days of supply, and the each unit has on the counter has a day supply count, or we can track by we can track it in another level of detail, which is primarily we use class fuel, ammo, and then particular exquisite munitions. Like, hey, if you only have let's say 40 hypervelocity weapons, well, we're going to track all 40 of those specifically, as opposed to 2,000 rounds of prism or 200,000 rounds of HE. So as an example. And then depending on your supply state, that also affects your ability to conduct operations. So that affects all US UCPVs, movement rates, and so on. And that's an example in the top right of how that works. Protection. This is the engineering type stuff. There is an overlap slightly, and this is a kind of a idiosyncrasy of Army doctrine. But air missile defense, nominally you think that might fit within protection, but it's really in fires. Now, there are some pieces that are in protection, and there are some pieces of protection that are in C2 and SEMA. So SEMA is EW. So there's kind of overlap between some of the warfighting functions in that way. However, so our focus in protection was engineering. So engineers where they can develop improved positions, they can create fortifications, they can lay mines, they can breach fortifications, and so on. And so each one of these, we have a set of, these are a set of what we call engineer points. So you're representing the functionality of an engineer unit, let's say an engineer battalion. It may have 6 engineer actions it can do every 24 hours. And so the kinds of actions it can do are listed over there on the right in that table. And you can apply it to various units or hexes or whatever. And so that, and then if the engineering unit gets damaged or retreated, then the numbers of actions or activities it can do is degraded. So that's how we do engineering. Oh, they can also help support river crossing. So then we also do SEMA in space. SEMA is the combination of cyberspace operations and EW. And we have done multiple engagements, and this is over years with SEMA in space with as subject matter experts, both at the Army Cyber Center and at the Space Missile Defense Command and the U.S. Space Force. And we've done a lot of different engagements with those, and we've worked with both of those groups to develop very similar to what a lot of other war games use, which is a set of activities you can execute that will impact both operational level and tactical level operation. So a lot of war games, they use action cards or so on. We don't have particularly action cards, but we have missions they can execute, which essentially are the same thing. If you say, hey, we're going to execute this, let's say there's 3 levels of cyber missions you can execute. One is the one you can only do once in the entire battle, because it's something you've been planning for years. And once you shoot it, it's done. And the bottom one is, the lowest one is that's something you're doing down at a division or brigade level, where you're trying to attack a cyber EW, you're trying to attack some enemy command control system. And space is very similar, but space is broader, and there you can affect a broad swath of if you're attacking GPS, or you're impacting the higher level command control, and so on. And so both of those, we have the very types of mission, and then we have defense. So each one of these is played dynamically in the operational war game by players from the Cyber Center and the Space Command or the SMDC, and they play out their planning, and then the effects of that, the dynamics of interactions between the space, red and blue space and red and blue cyber, those impact what's going on in the actual tactical wargame. Okay, soft, another place where sometimes it gets pretty short shift because what we do is we apply it in a very similar way uh, in that we've done space and cyber. So there's a set of missions, there's dozens of or tens of in the US they're called OEAs, but they're soft teams. The red guys have similar things, and our green forces, allied forces or host nations have similar. You have a lot of different teams out there. We don't. There are dozens of things, and we don't specify where each one is at each time at any time, but we say, okay, you have X number of these missions you can execute every 24 hours, which represents your ability to have units, assets in position to execute whatever these missions are. And there's a set of missions we've developed with the soft USASOC, the U.S. Army Special Operations Command, to flesh out what kind of things they can do. And you can have defensive parts too, where you can hunt down and get rid of the enemy soft as well. With similar type thing we do. Okay, so taking all those pieces, putting them together, all those pieces of representation, then we put everything together in this very this sequence of play. And the sequence of play, I'm sure everybody online has seen a dozen different ways a sequence of play. It shouldn't be dissimilar from a lot of the ones you've seen. What we play with is we do, again, like I mentioned before, when we play our full-blown war game, we do an operational game. One game turn is every 24 hours, but that game turn is 24 hours ahead of the tactical game. So everything that's happening up there is going to impact what's going on in the tactical game at the core and below on the next tactical game turn. So, like if you do the air interaction, where you determine how many sorties of tasks and air interdiction missions get through, those are then, after that happens on one day, then that's telling the tactical players, okay, for your operation, you have this number of assets you can apply to your whatever you're going to do. And so then we play, those guys are playing, that's a separate room with a bunch of red and blue players. Then the main room is the tactical game, where we have usually a blue player for every one of those warfighting functions, movement, maneuver, aviation, C2, etc. And then there are 3 or 4 or 5 red players, so they have to kind of combine to do they have to double up on doing different operations. And so we have both red and blue team. They do their planning, asset allocations, and then they do a briefing to the commander, and then that gets put into. Then we go into the actual tactical operations piece of the game turn, and then you can see what happens here. There's that you do the sustainment check, you do the shaping fires and all that. You check the intel state, and then you go through a series of the unit activations, which I kind of described earlier. And where you'll activate a brigade, or if they're playing brigades and you're activating a division, you do all that stuff and you activate the next brigade, etc., until you run out. Each side runs out. And often the red guys have way more activations than the blue guys. So the blue guys have to they can pause, they can defer an activation to wait to see what the red guys are doing, and so on. And so this whole war game turn here, typically when we play it in a full-blown game, it takes real world time. It takes 4.5 hours total. So we can usually get 2 game turns done every day. And by the 3rd or 4th day, the players have the mechanics down and so on, and we can easily get 2 game turns done every day. So that's 2 days. So you can see if you can do 2 days of operations, if you're looking at a battle, each week of gaming, you may get, let's say, 6 days of battle going to take place. Then the next week, you look at the other another alternative solution set or change in the red capabilities, and then you run the same war game again. And so that to do kind of a very simple run design. Or you can just do 2 days of games and then have 10 runs, or 6 or 8 runs in a run design. You can do it either way. Okay, so in summary, we leverage war games by applying them within what we call the Army Analytic Community Analytic Standards, which describes measurement space and a DCMP, and we leverage that cognitive process to pull out observations and build those up into insights that we then can use to answer study questions, study issues, and so on. And then when we actually apply it in a war game, it's very complex. So we can't get away with doing very simple war games anymore. The only place we can really do that is if we're playing a high-res war game. For example, if you're playing a company versus one or two companies of enemy assets, then you can play individual entities where, let's say, space is not a big player, as an example. So, but typically it's very complex. So when we build things out, we have to, our design of a war game, our whole business that we do, we have to be able to distinguish between alternative weapon systems, alternative force structures, and alternative TPP, or ways of conducting operation. And so to do that within this complex environment, we had to build out a robust kind of multi-attribute war game system to be able to meet those demands. And so that's where we are. So that is it. I guess we've got some time for questions.
Thank you so much, Paul. At this time, please type your questions in the chat.
Out of the briefing and look at the chat. Oh, yeah, the interface. Okay, so the interface, it's each player has a station where they have a standalone version of the vast R tool. And so it looks like a board game screen. Like there'll be a map. Let's see if I have an example of that down below in the slides. It'll have a map and a diagram of the battle space. So then so they'll see that. I don't have it. Sorry. They see the 2D map visualization on a screen. It's like playing a war game, and then they do their planning off that. Then they send their plan digitally to the main server where the VAST collates all that, and then it does a set of automated adjudications for the shaping fires. But then the unit activation, the players actually go up to the main screen in front of all the other players, and they move their units around. And they can either use a touch screen, or we can have somebody kind of do it for them, an operator kind of do it for them. And as they move their units around, they describe what the units are doing, and the red guys can do counters or so on, reaction moves or opportunity fires and so on like that as they're doing their action. So it's they have their own work screen, which has a instantiation of the tool, and then they see that when they actually go up, they use the interactive tool up on the screen.
Paul, before the next question, would you mind reading the question out loud?
Yeah. Okay. Sorry. Yeah.
Thank
So
you.
the first question was, what does the interface look like? The next question is how do you see large language models affecting the rounds and turns? So that's a very good question, and one of the places that is, we believe it's going to be uh, uh, produce a lot of fruit is in the sense of because we only have a handful of red players usually, just because of resourcing requirements, it would be very useful to have some AI or LLM build out using some decision rules that the red players have already developed that then will auto-generate the plans for every one of the red units. So we can only will need to have resource one or two maybe two red players in a big war game, so that they can just say, look at the red plan as laid out by the LLM, and then just say, yeah, execute or modify it and go. Yeah, that's a good one. We absolutely believe that. There's a separate aspect that we're going to use LLMs for scenario to help instantiate some scenario narrative development, but that's not directly related. The next question is how do you foresee what 2040 or later will look like at this whole level of detail? You get a lot of expert opinions first. How long does it take make a battle at this level of detail? Okay, so there's a whole industry out there in the Intel world and in the programmatic world that are that describe what the future looks like that. So there's a whole intel at the secret level and above of what we think each one of our potential adversaries is going to look like in terms of weapon systems capabilities, force structure, etc. So we pull that out of there. And then the blue side, we get it from the concept developers and the program managers that where we say, okay, well, an M1A2 SEP, whatever, 3 battle tank, main battle tank, it has these capabilities right now, but these are the anticipated deployed capabilities it'll have in 2040. And so we get that information from program managers or our our Army data pool. So that's how we anticipate that future environment. Now, we are not that I wish I had put in another slide. I have this future cone diagram I use that describes how we look at how we look at not being able to specifically identify what the future environment is going to look like. So when we build scenarios, we build where you have a starting state and then you have like a cone going out to the right from that, which represents time. And the cone over time, 20 years, 25 years out is pretty wide. Well, so we have a baseline scenario, which is what we think is the most probable future state. And then we have 3 or 4 other scenario settings that are outside the bounds of that in different ways. And so we kind of bound the problem that way to make sure that we don't just focus on that. So hopefully that answers that. Yeah, we get a lot of expert opinions. Yes, we do. Absolutely. How long does it take a battle? I'm not sure. To build out a scenario, it takes several months to go from a starting point to a new scenario. To build it out in a TWG thing, if we have the scenario, we can build it out within, I don't know, 6-8 weeks. If it's a brand new scenario. If you already have a lot of the force structure, it's just a matter of weeks to do it. Now, if you want to represent something new in the game system, that's another story. Depending on what it is, it may take longer. The next question from Greg is, how do you select players? Are the green suiters either on the red team? And what ranks do normally participate? And are the players always playing their career field? Let me start with the latter one. Yes, they always are playing their career field. We try not to have that. I've done games that way where they don't, not as useful and not useful at all to not do that. We select players, usually they're green suiters, the blue players are. The red players are usually not green suiters, they are Intel analysts that are TRAC, used to be TRAC, now it's T2Com, or Army Futures Command, both again T2Com. These are highly experienced red players that do this all the time. The ranks that participate the best when we execute war games, usually you don't want to have, you don't want to have a bunch of O6s and above in the game. You want to have majors and lieutenant colonels, and maybe a colonel or two, O6. But usually lieutenant colonels and majors are the ones you want participating as players in the game. And that's for a number of reasons. One of which is they are closest to the actual what's been going on in the field and so on. But also because depending on personalities, some people can dominate the conversation, and you don't want to alleviate that as much as possible. All right, the next question is, what principles would you apply to judge the effectiveness of complex blue fork capabilities holistically when you have so much data generated during the wargaming? Right. So that is the art of wargaming analysis. So we have hundreds and hundreds of observations that we capture, not counting the quantitative data that we pull out. And so the process that we go through that's why we have that structure, the hierarchy process, where we build out kind of the flow, the sequence flow of what happened, then the operational textual flow, and then pull out the insights. And that is so that we can build, and typically it's done by doing categorizations of what we've seen in the war game. So you will see patterns taking place. You will see players making decisions based on specific types of information that you can capture and put in there, and then you tie it all together. And that is highly war game specific, and that's the art. That's the art of putting it all together and building out those at some point those insights. And yes, it is very complex. Now, the beauty of it though is a lot of times what you're seeing when you pull out these war games, when you execute a war game, is you see things that you never would have thought you'd see before. Now, some of the players may, depending on the player, may say, "Oh, we would have thought of that anyway." Well, you didn't until we did the war game. One comment. However, what it does allow you to do is examine the dynamics of that specific interaction or whatever that risk is, etc. And it also allows you to understand. A lot of times, it's those new things that emerge are on the boundaries between, let's say, warfighting functions or capabilities. So, for example, I'll give you a good example. One is hey, the tank developers may develop a tank gun that can shoot twice the range as a current main gun. Well, that sounds great, right? Sounds great. But then when you look at the battlefield in Europe, very few, let's say that tank range, you go from 2,000 meters to 4,000. But then when you look at engagements in Europe, you never shoot a 2,000 meter range shot. You only shoot 700 meters or less, as I'm just giving an example. So maybe you ought to think about something different than the 2,000 kilometer, the double the range, unless you're going to be going to the desert all the time. So that's an example of those things that are emergent, and that's kind of it sounds like a no-duh example, but it is an example of what kinds of things we found. Any other questions? And if I didn't answer one of yours, go ahead and. Oh, here's another one. Sorry. What novel area that is offering great potential is combating the, yeah, yeah, right. So that's a good one. So we one of the things this war game was built to examine MDO and the new Army warfighting company. It's not built to specifically look at the kinds of things you're talking about. However, if we look at high res kind of applications of the TWG, we we can't apply it to that. Now, but I would not do that. I would leverage other games that we have already done that are not TWG to examine that kind of combating narco terrorism kinds of initiatives. And we have done dense urban environment war games, very high res. We've done civil affairs and soft war games that are highly detailed that look at those specific types of interactions. And so I would leverage a modification to one of those wargaming systems to examine that kind of environment. On the DCMP, next question from Alan is on the DCMP, how much do you rely on the observations of analysis versus direct surveys of the wargamers? Oh, right. So when we do this, a lot of times we do have a survey for the players, maybe at the end of each game turn, but a lot of times at the end of each game run, like each alternative set of runs. Um, um, so most of the qualitative data or player observation. Now, sometimes those observations may be our analysts sitting with the players and helping the players fill out data capture sheets that 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 as that have leading questions that say, hey, in your CONOPS development or your game turn plan, what were the key things that made you plan the way you did? And so that the analyst would help them flesh that out. So I would consider that a kind of a combination of the observer slash player doing a survey. So it's observers and the player inputs into those data capture sheets. So it's I would say half and half maybe on those. The next question is, how are you building in allies, NATO capabilities, logistics, transport requirements? Right. So whenever we play a war game, now it's with a combined scenario. So in Europe, you can imagine we have NATO members, host nation members of the nation states we're playing in. In Indo-PACOM, it's very similar. So we have, the Japanese, the Australians, whoever, and then wherever host nation we're playing in for that fight. And that includes log requirements and so on. And another consideration for log transport is the Army and Indo-PACOM that we have boats to get stuff around inside the theater, inside the AO, the operating area of operations, but we don't have the boats to get stuff from the U.S. to out there. So that comes from Transcom or somebody at Navy or whoever. And so, yeah, and there's a footprint, Army supply footprint for Air Force and Navy as well. So there's all sorts of interactions. And yeah, so we do build out all those. So when I say we have blue and red, we invariably have green units, which are host nation, or brown or gray units, which are allies, depending on whatever color of the day we're using. Next question, it says, it seems unknown discovery has the highest value. Yeah, sure, absolutely. Some of it is. Some of the stuff you know that you don't know it. Yeah, you're talking our buddy. Yeah. Anyway, this concept of the unknown. Yeah, that is right. So you don't know it. That isn't. Those are all the things that pop up like black swans kind of things. But there's a lot of things that you don't know, and you need to flesh out how those things, the details of those things. So there's a lot of that as well. And I agree there could be AI helping in there as well. I do agree. Those are all great comments. Good question.
Excellent. Do we have any last questions for Paul?
Welcome.
Great. Well, it seems that we have exhausted all the questions from our participants this evening. Thank you so much, Paul, for sharing your expertise with us and for your time this evening. And I look
Yeah,
forward to
thanks, man.
welcoming you all to our next webinar.
Well, hopefully I'll see you guys at Connections or more someday.
Sounds great, Paul. Have a good evening.
Okay, bye-bye.